this is Doriana from Team 1. This is part 2 of Project 7 for ChemLab. I will be showing you how to draw the Lewis structure for carbon disulfide. So to begin, we see that carbon is in group 14, meaning it has 4 valence electrons, and sulfur is in group 16, meaning it has 6 valence electrons. Now, according to the subscript, we can see that there's 2 sulfurs, so we should multiply the 6 by 2 and add them together. Now, 4 plus 12 equals 16 valence electrons that we will need to use to draw our Lewis structure. We will put carbon in the center because it is the least electronegative. Following that, we will put sulfur alongside of it. The 2 sulfurs alongside of it. Next, we will connect them by drawing single bonds that each count for 2 valence electrons. Now, you would think that we would add 6 valence electrons around each of the 2 sulfurs. However, we need to make sure that both carbon and sulfur follow the octet rule. And we can actually move the valence electrons between atoms and share them. So both the sulfurs and carbon follow the octet rule by creating a double bond, 2 double bonds. Now both the carbon and the sulfur are satisfied, and we only used the valence electrons that we had available. Looking at the 3D representation of CS2, we can see that both the molecular and electron geometry is both linear. The shape is determined by the hybridization of the central atom. Its steric number will equal 2, so it's sp hybridized, and it will be linear following a basic AX2 model. If there were lone pairs present in the carbon, then it would cause the bonds to be pushed together, decreasing the bond angle size. However, that is not the case. The bond angle for CS2 is 180 degrees, and CS2 is nonpolar because it's symmetric and the 2 sulfurs configuration is the same. The valence electrons that are shared between the sulfur and carbon is distributed equally, meaning there's no poles. As for the intermolecular forces, there is only dispersion present and not any hydrogen bond, since there is no hydrogen bonding with either oxygen, nitrogen, or fluorine. And there's also no dipole-dipole forces because that mainly occurs with polar molecules. Thank you for watching.